Hi, today we are discussing about the parallel processing. You people know what is parallel, right? Yeah, the similar operations will perform in either 1 minute or 2 minutes. The both will perform in a single time. The both will take the same time, right? So in the parallel processing, the main function is the CPU and the accumulator. The CPU perform the process with the help of the ALU, and the accumulator store the current operation result. It does not store the more result. It can store only one result, right? Let's take an example to understand about the parallel processing very deeply. A plus B. We have to perform the operation A plus B. So our problem is A plus B. We have to add the A plus B. What is A? Where we have to store the A. Where we have to store the B. How do we perform the add operation in the parallel processing? Now we are discussing about that. A. We have to consider two resistors R1 and R2. Those are the load resistors. The R1 will consider A and R2 will take the B, will fetch the operations of A and B. Then let's come into the points. Values of A and B are fetched into the resistors R1 and R2. It means the R1 will store the A value and R2 will store the B value. Fetched means it was taking. Fetched means taking. So R1, we have to perform the addition operation. What is R1 and R2? A and B. So which operation we have to perform? Arithmetic, and it is the addition operation we have to perform. So then the R1 and R2 will be sent to the ALU and it perform the addition operation, and the result will be stored in the accumulator. When the ALU unit is performing the calculation, the next data C and D are brought into the R1 and R2. It means this here we see here it was working parallel. After completing of one operation, it was completing the another operation, right? See, the R1 and R2 values are null. The A plus B operation was completed. So the R1 and R2 registers are now in idle position. So that we are fetching the C minus D operation in the R1 register as C and R2 register as D. So now finally the accumulator have already A plus B operation result, right? It will send those result to the another resistor, and it will store only current operation result, right? So the C and D, the C minus D operation will store in the accumulator. Then see here the last point. Since the accumulator value of the previous operation is present in R3, the result of C minus D can be safely stored in the accumulator. See here the previous operation of R3 value is stored in the accumulator is stored in the R3, and the C minus D value was stored in the accumulator. So this is the process which was working parallelly in one CPU. This total operations, many operations will perform in the CPU, and the calculations will perform separately. So here there was a diagram of concept of parallel processing. So the data was stored in the processor registers, and the processor registers are divided into 4 parts: arithmetic unit, shift unit, logic unit, floating point conversion unit. In the processor the data belongs to shift unit. The data was binary, and the data was requesting the processor, the CPU, that it want to the operation performed for it is shift unit, then the process register will pass those data to the shift unit. It perform the operation, and again the performed result will be stored in the process register in an accumulator. Okay, here the given below explanation is that what I explained. And the another one is, if the process registers have two types of data, one is the logic and another one is the arithmetic, and the data was requesting that the operation performed to that data is arithmetic or logic, and it sends the data to the arithmetic and logic unit, and the results are stored again in the register. I think you people can, I hope you people can understand my sound, my voice. So if you like this video, please subscribe, like, comment. If you have any doubts or any questions, please comment. I will explain in another video. And please like, share with your friends. Thank you.